Hi, welcome to Lab 4 of Physics 21L. How are you doing today? Oh, that's right, you can't answer. This is a video. Alright, well, the Lab 4 setup is very similar to the Lab 3 setup, so if you were confused by Lab 3, you're going to be confused by Lab 4. Does that make sense? Okay, I thought so. Alright, one thing that we're going to do a little bit different, we're going to add in is this guy right here. This is a multimeter. Can you say multimeter?
Multimeter.
Can you say it louder?
Multimeter.
Can you all say it?
Multimeter. Yeah.
Multimeter. Multimeter. Alright, so how do we use it? Well, it depends what we want to do with it. It can measure resistance. It can measure frequency even. It can measure F, whatever that is. It can measure current. And it can measure voltage. And temperature. And some other things that I probably don't know how to use on this. Okay, so how do we use it? Well, what we want to use is we want to measure voltage. Now there's two different kinds of voltage. You see this thing with the flat line and then the dots underneath it? That's DC voltage. You see this volt with the little twiddly mark at the end? That's AC voltage. We're really going to be doing DC voltage, not any AC voltage. So what you do here is you see this little thingy jigger here. You put it over to DC. Now, you also have to choose what scale you want to put it on. And we've got 200 millivolts, 2 millivolts, 20 millivolts, 200 volts, and on 1000 volts. Most of the time, I guess we're going to be in the 2000 volts. Yeah, we're going to be electrocuting everybody. Bring some small animals or things that you want to see cook. Now, we'll be either in 2 volt range or 20 volt range. So you put the little thingy there like that, 20 volt. All right. Now, what it says to do here is to turn this guy on and set him to 3 volts as measured by the multimeter. So what you do is you get your lab partner to connect himself across the voltage here, and then you turn it up really high, and then you probably have to talk to the police after that. Now you put the black onto the negative and the red onto the positive. Now I'm going to back up here just a little bit more, and actually you look at this connector here one more time. The black connector goes to COM, which it's not on right now, which would have been a really dumb thing. Alright, when it hurt. Too bad. Alright. So you want to make sure you're on COM, and the red goes to V or ohms or hertz. Alright, so I'm going to see if I can... Some of these used to have a stand, but they don't anymore, so I'm just going to pop it up like this. And I'm going to get Sean to come over here. Sean, come over here for a minute and hold this in place. So, 'cause I don't have 3 hands. What you're going to find, thank you, Sean. What you're going to find is that the voltage reading off of here is not going to match the voltage reading off of there. So let's, first of all, we turn the current up a little bit because that's like a faucet. All right. So now it's good. And then we're going to turn the voltage up. All right. Now it says 1.13 there, and this is 1.1. So it's pretty close. You might get lucky. But it says to turn it to 3 volts as measured by the multimeter, or DMM. Can you say DMM?
DMM.
Very good. So now we change it to 3 volts. Ooh, I'm good at this, aren't I? Maybe. Oh, 297. This is a pain. 301. Crap. 298. 301. 269. Isn't this fun?
Do you want me to pause it and we can just come back in an hour?
No, I think you guys should suffer as much as I'm suffering having to watch this. And there we go, 3.0 exactly, right? Yeah. Okay.
Is it actually?
No, it's 2.98. Shut up, Sean. All right. So now it says to just leave it there at 3 volts. And we're done. Okay? Now if we look here, what we have is the thing is set up with, thank you Sean, your service was invaluable. we have this thing set up with two 100 ohm resistors in series. Now, the power supply voltage, if you look on your lab sheet, and I'll have an Excel spreadsheet, you would put down the power supply voltage is 3 volts. And you calculate the equivalent resistance of the circuit. Well, do you remember when we did series resistance, what we said was that the equivalent resistance is the sum of the resistances. So in other words, 100 plus 100 is 200. That's easy. All right? Now they ask you to calculate the expected voltages across each resistor. It's going to be different for the two resistors, or the two of them. And let's just show you why that's the case. We turn our multimeter back on, and we just measure the voltage across one of the resistors. Remember, we got 3 volts VTO. And what do we get for one of them? Well, it's about 1.5. I got the two terminals reversed, so, right? 1.5 volts. And on the other one, we'll probably get what? What do you think? Because remember, we did this last lab. V total is equal to V1 plus V2. So this is going to be about 1.5 volts there also. Okay, so that makes sense. What a surprise!
No one wants to see you. It's all about the lab.
Okay. So, we just did all of part 1 up to part C. It says calculate the expected current drawn by the power supply, the total current. Well, that's just going to be the total voltage divided by the total resistance. Did I do that right? Yes, I did. Okay. And the current through each resistor. Now, let's think about that. When you have resistors in series, are they going to see the same current or a different current? Think about that. Remember the lab you just did. Literally, in my case, because I'm doing this just after you finish the lab. All right. Now it says, oh, that's bizarre. It's got the same question twice. You only have to answer it once. All right. Now the next thing you're going to do is to set this up over here. Let's just turn the power supply off for a minute. And I've got this thing set up with two 100 ohm resistors in parallel, plus another one in series. We'll use that one later, so I'm just going to disconnect that one for now. Okay, just like that. Now that's in here. And we're going to take our 3 volts, and we'll connect it up to here, like this. Okay, just like we did in the last lab. Not hard. Okay. Now we calculate the total equivalent resistance of the circuit. Well, we did that too. That's just, remember, R1 times R2 over R1 plus R2? R1, R2 over R1 plus R2. Easy enough. Now, we know we got 3 volts coming off of this power supply if I turned it on. So what is the voltage going to be across the parallel resistors? What do you think? What do you think? If I've got 3 volts coming out of the power supply, what are the parallel resistors going to see? What's this one going to see? What's that one going to see? Do you remember? What do you think, Michaela?
They're the same.
And what's it going to be?
Whatever it is.
And if it's 3 volts, it's going to be
3 volts.
3 volts. This is easy. Wow. Yep. Then we're going to measure the voltage. So this is actually not that hard of a lab so far. I'm almost done with it. I'm good at this, aren't I? Yeah. All right, so let's try this. And what do we get? What does it say? Measure the voltage across each resistor. All right, so I do this. And I get about 3 volts. And I do this. And I get the same. Big surprise. I am so shocked. I am just as shocked as if I had connected myself across the power supply. Okay. Now, that's easy. Then it tells you that it wants you to calculate the expected current drawn by the power supply and the current through each amp. Well, that's not hard either. And then it wants you to measure it. Now, when you measure it, this is where things get just a little tricky. Just a little. Because first thing you have to do when you're measuring current is you pull the black cable out and you put it from the you move it over to milliamp. All right? Then what you are going to do is you're going to disconnect this guy right here. Let's say we want to measure the current through everything. Oh, actually, Greg got this a little. That'll work. It'll work. All right? We put this one here like this. Careful not to hit your hand to it. Use your lab partner. And then we put this one. Now we got to set this thing, the dial here, to current. And we want to set it to DC current. And you set it high because you can always set it low later. And you put it here like that. And what you get is that it sees no current draw at all, which means we're probably set too high. So we notch it down a bit, and we still see no current. So we notch it down a bit more, and I'm really hoping I didn't break something here. I'm thinking that this might be, the fuse on this thing might have been burnt out already. Greg gave me a pile of fuses, but I'm not going to bother putting them on while you guys watch. So that's how you measure current. And hopefully for you it will work and you won't look like an idiot. But that's okay, I don't mind. I am going to hook it back up. And now I'm going to turn it back on. And it's drawing current, so I think, yes, I think we lost a fuse here. Oh, no we didn't. Yes we did. Do not hook it up to any other ports unless I tell you to. So, that's how we measure the current. That was easy. All right. So essentially we've done the same kind of thing that we just did in the last lab. But hopefully this time you did it faster. All right, now for the next part, what we're going to do is turn this off. And now we're going to add in a third resistor here. And we can do it just like this. Now we have a mess because I did something wrong. This one here. It goes over here. Now we have two resistors in parallel and one resistor in series. So what you have to do here, if you want to figure out the equivalent resistance, it's a two-step process. One is you take the two parallel resistors and you make an equivalent resistor for those. That's easy. Now you have this is going to be 100, so that'll be 50 ohm. And then what you do is you got this thing here, so now you have two resistors, your R equivalent here and this one here. You make that into series and you can add those two together just like we did before. So first you do the parallel, then you do the series. It's important to do things in the right order too, because you can't really do it in series first and then add it up in parallel. And now you do the same kinds of measurements that you did before, but you're using, again, the multimeter instead of the Logger Pro. So, then you go to the next page and guess what? You're done! So you guys should be done with this lab and nothing flat, right? Okay, I will see you in the physics lab.